everyone, let's see this particular question. So here the question says that let x denote the greatest integer function, and one function is given over here. We are supposed to find the domain of the given function. Once we'll be able to find the domain of the given function, then we can find whatever is asked over here. So yeah, the given function is f of x is equals to, as we can see, greatest integer function and modulus function both are involved over here. Let's write the function first. Now to find the domain of this function, we need to understand this inside the root, whatever is there, that needs to be greater than 0. Since inside the root there is a rational function involved here, so yes, we have to be careful while saying that it can be equal to 0, because we know denominator cannot be equal to 0 over here. Let's write it. So this needs to be greater than 0. Now if you will look closely, you will realize if a rational function is greater than 0, that means that numerator as well as denominator should be positive. This is one of the possibility. Or maybe numerators and the denominator, that needs to be, both needs to be negative, then and only then entirely it will be bigger than 0. Okay, making sense? So yeah, with this two possibility we will proceed. So the first possibility, the numerator and the denominator both needs to be bigger than 0. So let's write that. Now we can take that here numerator can be equal to 0 as well, but not the denominator. Okay, with this understanding we will move ahead. Now one by one let's solve these two inequalities. So now the first inequality, that mod of greatest integer function x minus 2 is greater or equals to 0, can be written as mod of greatest integer function x is greater or equals to 2. Now think about it. Suppose, just let's focus on the modulus function first. So inside the mod, let's say u is there and that u is bigger or equals to 2. So on real line, if you will look closely, are you understanding that here the number, okay, can be 2. Inside the mod it can be 2, okay, or bigger than 2, maybe 2.1, maybe 2.2, maybe 2.5, maybe 3 or 4 or 5. Okay, these are the numbers which will satisfy our inequality if we are just focusing on the modulus function for now. Okay, or it will be smaller than minus 2. Yeah, it can be minus 2 as well. Okay, if you will take minus 3 modulus function, okay, this mod of u greater or equals to 2, this will be satisfied. So somehow we are getting the idea that if we are focusing on just the modulus function, our solution region will be towards the left of minus 2 and towards the right of positive 2. But here greatest integer function, that is also involved, so we have to be really careful over here. So let's take few example to check with the numbers. For example, if I am taking minus 2, okay, mod is there, greatest integer function involved minus 2, and the result will be this greatest integer function will give just minus 2 and mod will make it positive. So yeah, this is satisfying our inequality. If you will take a number towards the left side of minus 2, let's say minus 2.6. Now as we know, greatest integer function will give nearest integer which is smaller than minus 2.6, that is minus 3. And yeah, we are going to get just 3. This is also minus 2.6 is satisfying our inequality. So this region is still coming in our solution. But what about the numbers which is towards the right of minus 2? Okay, let me highlight over here. I am talking about the number. What about these numbers? Okay, minus 1 or maybe minus 1.5. Okay, these number will also satisfy our inequality or not. Let's check that. So suppose we are taking minus 1.5. Now greatest integer function will give the nearest integer which is smaller than this minus 1.5, that means minus 2. And yes, still we are getting 2. So yeah, this number is satisfying our inequality. What about minus 1? As we can see, minus 1, the greatest integer function will return back the same number and mod will make it positive. Now this minus 1 is not satisfying our inequality. Okay, this is our inequality. Let me highlight it with yellow marker. This is the inequality which we are focusing on. Okay, this is not satisfied by this minus 1. So now we can highlight the solution reason. We can say that from negative infinity to negative 1. Where negative 1 is not included, we will take the open interval over here. Let me mark it. Yes. So this is our solution reason. Towards the right as well, we have to check in the same manner. So suppose I am taking a number positive 1 this time, and it will return back the same 1, and we are getting just 1. And clearly we can see this number is not satisfying our inequality. Okay. Now if we will take a number which is slightly bigger than this one, maybe 1.2 or 3 or 1.4. So from here we can understand that the numbers like this, that is 1.5, 1.6, 1.9, 1.999, this will always give 1 from the greatest integer function. It will come out as a 1 and mod will give return back the same 1. Okay. So these numbers will not satisfy our inequality. What about 2? So yeah, we can see 2 is satisfying our inequality. And if you will take a number which is slightly bigger than 2, maybe 2.5, this is also satisfying our inequality. So yeah, towards the right direction, we can see our solution region will start from 2, including this 2. Our solution interval is from minus infinity to minus 1, union 2 to infinity. Now let's take the other inequality, that is mod of greatest integer function x minus 3 greater than 0. Let's solve this inequality as well. So here also, just like the previous case, we will be, just for now, let's focus on the modulus function. So yes, let's draw the real line for better understanding. Minus infinity to positive infinity. Here 3, negative 3. Now this time here equality sign is not there. So we cannot say that x can be positive 3 or maybe x can be negative 3. We cannot say that. Okay. Now here as well, let's take few examples. So suppose we are taking minus 3.8. This will give us just 4. And yeah, it is satisfying our inequality. What about the number which is towards the right of negative 3? Maybe minus 2.7. And this is giving us minus 3. That is just 3. And yeah, we can see this minus 2.7. This is not satisfying our inequality. Okay, so the solution reason will start from negative infinity and will go till negative 3, where negative 3 will not be included. What about the other numbers, the positive numbers? So yeah, let's check. If we will take the number 3, we can see clearly, if we will take the number 3, equality sign is not there, inequality will not be satisfied. What about the number which is very close and close and close to 3, that is 3.2. So yeah, from here as well we are getting just 3, and again 3.2 is not satisfying our inequality. Similarly, if you will take 3.4 or maybe 3.5 or maybe 3.9999, okay, you will find that these are the numbers which are not satisfying our inequality. What about a number that is 4? If we will take 4, then what will happen? So if we will take 4, then we will be getting just 4. And yeah, this is satisfying our inequality. So yes, for this particular inequality, the solution reason will be minus infinity to minus 3. Open interval minus 3, union, close interval, it starts from 4 and will go till infinity. Now we are done with case 1. Let's write the final solution for case 1. That means the intersection of both the solutions. Yeah, we need to take the overlapping region for both these solutions. So the final solution for case 1 will be, this is going from negative infinity to negative 1 and this goes from negative infinity to negative 3. So we'll be taking negative infinity to negative 3. Union, this starts from 2 and going till infinity. The other one starts from 4. So okay, so we'll be taking 4 to infinity, only the overlapping region. This is the final solution for case 1. Now we need to solve in a similar manner case 2. This one, where the numerator can be equal to 0 but not the denominator. Let's solve these two inequalities one by one. So this one must be smaller than or equals to 2. Now you can understand on real line, if mod of a function is smaller than or equal to 2, that means it must be lying in between minus 2 to positive 2, right? Now here greatest integer function is also involved, so we have to check with few example. Let's check that. So suppose we are checking for a number that is minus 2.8. Okay, minus 2.8 will give us the nearest integer, which is closer to this one, is negative 3. That means just 3. And yeah, this is not satisfying our inequality. What about the number minus 2? So yeah, minus 2 will give us only 2. Okay, positive 2, and this is satisfying our inequality. Okay, so our solution region starts from negative 2 and it will go till, let's check that, will it go till positive 2 or beyond that. So if we will take few more numbers, let's say we are taking 1.9. This will give us nearest integer which is smaller than this one, that is 1. Okay, and yeah, it is satisfying our inequality. What about the number which is beyond, like towards the right side of positive 2, maybe positive 2.7. So if we'll take positive 2.7, we are getting just 2. And yeah, this still is satisfying our inequality, and this will be valid for the numbers like 2.8, 2.9, 2.999. Will it be valid for 3? No. So yes, from here we can see the final solution, the solution region starts from negative 2 and going till positive 3, where 3 is not included. Now let's solve the other inequality. So here as well, let's draw the real line. So here as well, if we'll take a number, let's say minus 3.5. Now this will give the answer as a 4, which is not smaller than 3. Okay, what about this? If we'll take a number that is very close to minus 3 but towards the right side, that means minus 2.8. And this is giving us just 3. Still it is not satisfying our inequality. What about minus 2? This will give us just 2, and yeah, this is satisfying our inequality. So yeah, here as well our solution region start from negative 2 and it is going till which number? Let's check that. If we'll take positive 3, it is giving us just 3. And we can clearly see this is not satisfying our inequality. What about the numbers which are very close to 3? Okay, maybe 2.7, positive 2.7. Now this will give us 2. And yeah, this is satisfying our inequality. So here as well, the solution region will start from negative 2 and will go till positive 3. Since we have to take the intersection of these two cases, and we can clearly see these two cases are exactly same. So yeah, from case 2 we are getting this final solution, as the solution reason will start from -2 and will go to 3. Now the case 1 solution and case 2 solution, let's combine these two solutions. So this was our case 1 solution and case 2 solution is also here. Let's combine them and write the final solution. So minus infinity to -3 union -2 to 3 union again starts from +4 and will go till infinity. Now if we will compare this final solution with the given arrangement, let's compare that. Here the given arrangement is minus infinity to a union b to c union 4 to infinity. When we are comparing the obtained solution with the given arrangement, we can clearly see a is -3, b is -2 and c is +3. Now here we are supposed to find a plus b plus c. Let's do that. -3 plus -2 plus 3. 3 and 3 cancelling out each other, and the final answer is -2. Let's see the options. So yeah, here option C is the correct option. I hope you understood the entire solution. If you are having any confusion, please comment in the comment box. Thank you.